Let's talk about a new technology that honestly sounds like it was pulled straight out of a sci-fi movie. But it's not. It's real, and it's already in operating rooms. A company called Medivis is using AI and augmented reality to completely reshape spine surgery. We're going to dive into how this surgical X-ray vision is becoming a reality right now.
So let me just start with this question. What if a surgeon could literally see through a patient's skin during an operation? Like, what if they had actual, real-time surgical X-ray vision? It sounds impossible, right? Well, that very idea is the key to this whole incredible leap forward.
Because that future, well, it's already here. Medivis just got FDA clearance for its spine navigation platform, and what you're seeing here is it in action. It uses a combination of AI and AR to give surgeons a live holographic guide while they operate. And this isn't just some prototype in a lab. It's being used in U.S. hospitals as we speak.
Okay, so what does this new horizon actually look like? For the surgeon holding the tools and for the patient on the table. We're about to get into the nitty-gritty of how this groundbreaking tech works and what it must feel like to be in that room.
This right here is the absolute wow moment. Imagine you're the surgeon. You look down at the patient, and floating in the air, perfectly aligned with their body, is a detailed 3D hologram of their own spine, built from their CT scan. It gives you this unbelievable view of the exact anatomy you're about to work on.
So how in the world does this actually work? Well, the core idea is surprisingly simple to wrap your head around. The best way to think about it is like a super advanced GPS, but instead of guiding your car through city streets, it's guiding a surgeon's tools with pinpoint accuracy through the human spine.
The magic behind all of this is augmented reality, or AR. What that really means is the surgeon isn't looking away at some 2D screen on the wall anymore. They're wearing a special headset that lets them see everything in the room, the patient, their tools, but with this crucial layer of digital information, that 3D spinal model placed right on top of their real-world view.
Here's an even better analogy. Think about a plumber who needs to find a pipe inside a wall. The old way is a lot of knocking and guesswork. This new way, it's like handing them a digital blueprint of the house and a laser level that projects the exact location of the pipe onto the wall. No guesswork. That's the kind of precision we're talking about.
So what makes this whole thing tick? It's really a team of 3 technologies working together perfectly. First, you've got AI-powered vision that's analyzing the patient's anatomy in real time. Second, you have the AR headset that puts all that info right in the surgeon's line of sight, totally hands-free. And third, it all responds to hand gestures and voice commands, so the surgeon never has to break concentration.
Now, you might think something this advanced would be a nightmare to use, but no. They've boiled it down to a super clear 4-step workflow. First, you prepare by loading the patient's scans. Then, you plan out the entire surgery, visualizing exactly where every screw needs to go. Next, you register the hologram, which is just a fancy way of saying you line it up perfectly with the patient. And finally, you navigate, using that hologram as your real-time map. Simple, smart, and so powerful.
And this is the view. This is the aha moment. This is what the surgeon sees through the headset. You can see the real patient, the real surgical site, and then that holographic guide showing the exact path for the instrument. It basically turns this incredibly complex anatomy into a clear, interactive roadmap.
Okay, the technology is obviously incredible. It's futuristic, it's cool, but so what? Why does any of this actually matter? What's the real impact of having this, almost superhuman level of accuracy in the operating room?
Well, the impact is precision on a level that is just hard to comprehend. The system is accurate to a sub-millimeter level. To put that in perspective, we're talking about the width of a single human hair. Now, in spine surgery, where 1 millimeter can be the difference between a perfect outcome and a lifelong complication, that is a total game changer.
And when you put the old way side by side with the Medivis way, the difference is just night and day. The old way? Constantly craning your neck to look at a flat 2D screen. More radiation from X-rays, a huge physical strain on the surgeon. The Medivis way? Your head is up, you're focused on the patient with a 3D guide, and you're reducing radiation while massively improving accuracy. It's not even a close call.
So think about what this does for the surgeon. Their job just got so much better. No more chronic neck strain. They can control everything with their voice or a flick of their hand. And it's designed to fit right into the ORs they already have. All of that adds up to a huge boost in confidence and, of course, precision.
And of course, all those perks for the surgeon translate directly to better outcomes for the patient.
And that's what it's all about, right? Surgeries are more precise, more tailored to your specific body. That incredible accuracy means fewer complications, which means shorter recovery times. And, bonus, less radiation exposure for everyone.
You know, the president of Medivis, Dr. Christopher Morley, he really hit the nail on the head. He said that surgery is entering a new era where computers aren't just tools. They're actively enhancing a surgeon's precision, speed, and efficiency. This isn't just a small step up, it's a whole new chapter.
So, whenever you see a technology this revolutionary, you can't help but wonder, okay, what's next? I mean, if you can bring this kind of precision to something as insanely complex as the human spine, where else could this go? It really feels like we're just scratching the surface here.
And the company's vision is absolutely huge. The CEO, Dr. Osama Chaudhry, talks about a future where this kind of navigation transcends boundaries. What he means is, it's not going to be stuck just on spines. And this isn't just wishful thinking, it's already happening. Medivis is already developing systems for incredibly delicate brain surgeries and for prostate navigation. Just imagine the same holographic guidance being used to remove a brain tumor or to repair a heart valve. The spine is truly just the beginning.
Which kind of leaves us with this final really big thought to chew on. With technology that gives surgeons this level of guidance, this superhuman precision, are we witnessing the beginning of the end for human error in the operating room? It's a pretty profound question to think about as this new era of surgery begins to unfold.